So today's topic is ammonia. Its molecular formula is NH3 and it is gaseous compound. Ammonia is gaseous compound. Now why it is called gaseous compound? It is gas. Now why it is called compound? Since it is made up of, we can see clearly how many nitrogen? One nitrogen. It is composed of one nitrogen and three hydrogen. That's why it is called gaseous compound, and it was first prepared by Antoine Lavoisier. Prepared by Antoine Lavoisier. First prepared by Antoine Lavoisier, chemist. Antoine Lavoisier. This gas, ammonia. It is gaseous compound made up of one nitrogen and how many hydrogen? Three hydrogen. Now, after that, it is found in free state also. It occurs, you can say, it occurs in free state as well as in combined state. Free state and combined state. It occurs. Free state means we can get in air, okay, atmosphere, air, soil, we can get nitrogen, ammonia, that is. Similarly, in combined state, we can get in salts like ammonium salts. You can write ammonium salts like ammonium chloride, NH4Cl, like ammonium sulfate, etc. So this is about occurrence of ammonia gas. Okay, now we will talk about molecular formula of ammonia. After this, molecular formula is NH3. Molecular structure of ammonia. Molecular structure I will show. NH3 molecular formula. First, let me write. What is the molecular formula of ammonia? NH3. This is molecular formula NH3. Molecular structure now. Molecular structure of ammonia NH3. Molecular structure of NH3. Let's see. How many nitrogen? One nitrogen. Nitrogen is 1, hydrogen is 3. So first nitrogen. You draw nitrogen. For nitrogen 7p7n. First cell consists how many electron? 2 electrons. Second consists how many? Second consists 5. Yes. So I will draw here 1, 2, 3, 4, 5. So what is this? This is atomic structure of nitrogen. So one nitrogen drawn. How many hydrogen? 3 hydrogen. How many hydrogen? 3 hydrogen. Let's see for hydrogen. So here one hydrogen. One hydrogen here. one hydrogen here. So we know that in case of hydrogen, one proton, zero neutron. One proton, zero neutron. One proton, zero neutron. So how many electrons of this hydrogen? We can show one. Yes. Atomic number of hydrogen is 1. Atomic number of hydrogen is 1. So how many electron? 1 electron. So this is molecular structure of NH3. This is H, this is H, this is H, and what is this? This is N. Nitrogen, here also hydrogen, here also hydrogen, here also hydrogen. So you can show like this also, sharing of electron here. 1, 2, 1, 2, 1, 2. And how many remaining of nitrogen now? After sharing, how many remaining? How many remaining? 1, 2, 2 remaining, no? 2. We can show like this also. So this is molecular structure of NH3. Next topic is general methods of preparation of ammonia. How it is prepared generally. So first method is by heating ammonium salt. You take ammonium salt like ammonium sulfate. Let me take, like I am taking here ammonium sulfate, NH4,2SO4. This is ammonium sulfate. What is this? Ammonium sulfate. Valency of sulfate is 2. That's why I have to write here 2. Ammonium sulfate. Now it is heated. What happens? When it is heated, remember that whenever there is ammonium, this ammonium gives ammonia, that is NH3. Okay? And then this here remaining H, here remaining SO4. H and SO4. This gives here S2SO4. That is sulfuric acid. What we need here? We need here NH3. So to balance this, hydrogen 4 to 8. So I'll keep here 2 to balance. I'll keep here 2. Nitrogen balance 4 to 8. So 3 to 6, 6 plus 2. I think balance. So this is number 1 method. Number 2 method, by heating ammonium salt with acid. Ammonium salts with acid. Like example, I'll write here reaction. I'll write reaction here. Take ammonium salt like NH4Cl. NH4Cl. Take one base, okay, with acid. No, here with acid. Acid with base. With base, not acid. With base, okay. With base, it gives. With base, right? Okay. With base. So ammonium salt, take one base. You can take potassium hydroxide, sodium hydroxide. You can take calcium hydroxide. If I take calcium hydroxide here, okay, OH2. By heating this, what we get? Remember, so heating this, what you get? Look at here. Calcium is metal. Calcium is metal. Metal plus charge always. Cl is minus here. NH4 plus. So plus react with minus. So what it gives? It gives Cl2. Valency of calcium is 2. That's why Cl2. Now what I said, whenever there is ammonium salt, one product will be ammonia always, NH3 plus. Now what is remaining here? Remaining here OH. OH always gives water. And this gas you show by upward arrow. Upward arrow, gas you show by upward arrow. So this is another way. You can take another example also, like you have ammonium sulfate in this way. Ammonium sulfate you can take. Ammonium sulfate plus another base like potassium hydroxide you can take, and then you can do K react with SO4. It gives K2SO4 plus here, from here always NH3, and plus OH gives always water. In this way also you can do Zala methods. Already balanced, I think, no? Not balance. Hey, balance this chemical reaction. Balance, what do you get? How to balance this? 3. So nitrogen here, nitrogen 1. Hydrogen here, 6. To make hydrogen 6, here 3 plus 2, 5. So what you can do? Oxygen 2. So I'll keep here 2. Oxygen balance. 2 to 4. 7, no? 7. 7 here, 6. If I keep here 2, then what happens? Check it now. 10. Match. 3 to 6, 2 to 4. Balance. Okay, next topic is lab preparation of ammonia. Lab preparation of ammonia. So for lab preparation, first of all, we need principle always. For lab preparation, we need principle. So what is the principle for this? What I have to write under principle? So first of all, you have to make mixture of ammonium chloride, taken NH4Cl, mixture of ammonium chloride and calcium hydroxide. Calcium hydroxide is also called lime water. In the ratio 2:1. In the ratio 2:1. Okay, it is taken in the ratio 2:1. And after that it is heated. First of all, mixture of ammonium chloride and calcium hydroxide is taken in hard glass test tube, and then it is heated. When it is heated, then what is obtained? Then ammonia, NH3 is obtained. This you have to write under the principle. Mixture of ammonium chloride and calcium hydroxide. in the ratio 2:1 is heated, then ammonia is obtained, and ammonia is collected by it is lighter than air. Carbon dioxide heavier than air, it is lighter than air. That's why downward displacement of air. How it is collected? By downward displacement of air. How it is collected? Collected by downward displacement of air. Air down, it means air down like this. You have to keep gas jar in this inverted. Downward, air downward. So it is called downward displacement of air. So this is under principle you have to write. We need two chemicals, ammonium chloride, NH4Cl, another calcium hydroxide. Calcium, this is base, calcium hydroxide, also called lime water. So now reaction, time for reaction. I'll write reaction here. So reaction for this principle, right? Reaction. So NH4Cl plus calcium hydroxide 2:1. So what I have to write here? 2. Here 1. 2:1 means here 2, here 1. 2:1. 1 no need to show. This 1 no need to show. So what are the product? Here? See, calcium react with Cl, so it gives Cl2 plus ammonium gives ammonia, and here remaining OH gives water. Ammonia you have to show upward arrow for ammonia since it is gas. Balance it. 2 4 8. I'll keep here 2. So 2 4 8. Hydrogen 2. 10. 2 3 6. So I have to keep here 2. Here also 2. Now I think balance. So this is reaction for lab preparation of ammonia, NH3. Okay, now what are the apparatus required? So what are the apparatus? Chemicals, you know. What are the chemicals? Chemicals already I said. Number 1 chemical is NH4Cl, ammonium chloride. Number 2 chemical is calcium hydroxide. These are the chemicals. And externally what we need? Externally we need heat. In that reaction, so sign of triangle also in that reaction. While writing reaction, this reaction, NH4Cl plus CaOH2. You show here like triangle. Triangle means heat. This also you show. Okay. Chemicals. Now what are the apparatus? What are the apparatus required here? Also apparatus also. So first of all we need apparatus, hard glass test tube. Whenever heating means we need hard glass to sustain the heat. We need, okay, hard glass test tube. We need hard glass test tube. Yes, stand also. Stand. This is. Similarly, we need heat. Bunsen burner, right? Heat, source of heat. So what we need? We need burner. This is burner, eh? Connected to cylinder, and here heat, fire. We have to keep here that mixture we have to keep here. This is mixture of NH4Cl plus calcium hydroxide. Okay. Now from here we need one cork. You have to make airtight also, no? And delivery tube here. Delivery tube. This is cork. We have to make airtight. Cork. And this is delivery tube. And delivery tube is another first end, second end. Inside there is we have to keep here lime tower. Now why it is kept lime tower? I will say lime tower. Lime means calcium oxide, lime tower. And here only we can collect gas. Yes, and for that also we need a stand. We need here a stand. Another stand here. So what is this? This is called delivery tube. These are the apparatus. Delivery tube. What is this? Hard glass test tube. Hard glass test tube. This is cork. This is Bunsen burner. This burner. And next delivery tube. This is called lime tower. What is this? Lime tower. Tower of lime. Here calcium oxide. Calcium oxide CO. Calcium oxide CaO. Calcium oxide. Lime tower. And this is gas jar. This is called gas jar. Gas jar to collect the gas. And as I said, it is collected by downward displacement of air. Since it is lighter than air. Ammonia is lighter than air. So collected downward displacement. Now what happens? When it is heated, when this mixture is heated, what happens? Ammonia is formed here. When it is heated, ammonia is formed. Here NH3 is formed. Ammonia. NH3. Ammonia is formed. Ammonia through this delivery tube first passes through lime tower. Now, listen one thing. What is the reaction? Let me write the reaction. It will be clear. Whenever ammonium chloride, NH4Cl, react with calcium hydroxide, then what happens? Formation of calcium chloride plus what we need, our requirement is ammonia, formation of ammonia upward, and plus water. You get here. To balance this, what you have to do? Nitrogen here, one nitrogen. I have to keep here 2, Cl2. So 2 here. Balance 6, 8, 4 to that, yes, 10. I have to keep here 2 more 2. Now balance. Now look at here. When ammonia is produced, along with ammonia, what is produced here? Water. So this ammonia you will not get in dry form. This is in moist form. So now that moisture in this ammonia, there is the moisture. To absorb that moisture, what is used? Lime tower. What is the use of lime tower? To absorb that moisture from the ammonia. That means whatever you get here ammonia, that is, here you will get ammonia. This ammonia is in which form? Dry form. Because of lime tower. Lime tower, calcium oxide absorbs moisture. So we can get ammonia in dry form. And you have to be careful, like it should be slanted, hard glass test tube. You cannot keep like this horizontal. We cannot keep like this horizontal. It should be slanted, inclined. Now what is the reason behind that? It should be inclined. If we don't adjust like this, then what happens? Water is produced. Because of this water, what happens? Water also heated here. When water is heated, what happens? Water change into steam. That steam gives pressure to the hard glass test tube. That means chance of cracking. If you don't keep slanted, then what happens? Chance of cracking of hard glass test tube because of this water. Water is produced, and because of it, water change into steam. That steam exerts pressure on the wall of hard glass test tube. That's why it is inclined. Okay, more about this in next class. Okay.